All right, let's dive right into this explainer, because right off the bat, we need to shatter a massive misconception. When most of us hear AI, we instantly picture endless lines of code, right? Sleek software, ultra-advanced microchips. But honestly, we're missing the much bigger, much heavier picture here. It turns out, NVIDIA's CEO Jensen Huang is quietly orchestrating, literally, the largest physical construction boom since the interstate highway system. We aren't just building digital brains anymore. We're pouring the massive concrete skeletons actually needed to house them.
And just listen to how Jensen Huang phrases this. He's laying out a total paradigm shift. He's explicitly telling us that the cloud is no longer some invisible, magical digital space floating in the ether. Nope, it's a massive, heavy industry manufacturing plant. It's a very real, physical place where raw data gets pumped in on one side and intelligence gets manufactured and pumped out the other. And to actually pull that off, you need infrastructure on a scale that humanity has barely even attempted before.
So we are officially leaving the old era in the dust. I mean, for 20 years, we built data centers that were basically just quiet warehouses, giant boxes filled with ambient AC and some blinking server racks. But the new AI generation factory? Totally different beast. It demands a level of physical infrastructure we haven't seen before, mostly because these dense clusters of silicon run incredibly, unbelievably hot. You can't just blow cold air on them anymore. You need serious, heavy industry thermal solutions just to keep the whole thing from melting down.
And that brings us to a frankly staggering number. Over the next 4 to 5 years, global spending on AI infrastructure is projected to blow right past $1 trillion. $1 trillion. And just to be super clear on what that cash is buying, it's not just software licenses and cloud subscriptions. That $1 trillion is buying millions of tons of concrete, thousands of miles of copper wire, high-voltage transformers, and endless mazes of liquid-cooled piping. We are talking about a physical spending spree that is literally going to reshape our skylines.
So with a massive physical build-out like that, we're seeing entirely new mega careers pop up. Let's look at the first one, high-voltage electrical architects.
This taps directly into the single most urgent bottleneck in the whole AI supply chain, massive, gigawatt-scale power distribution. To power just one of these mega AI campuses, you need the equivalent electricity of an entire small city. We're talking actual gigawatts here, like enough juice to send Doc Brown back to the future, except you need it just to keep a single AI factory humming 24/7. So back in July 2026, NVIDIA actually had to start partnering directly with utility companies to fund apprenticeship programs. They don't just need your standard residential electrician. They are looking for master electricians who really understand complex load balancing, medium voltage switchgear, and high-density power. And hey, if you can read a high-voltage schematic, you're easily looking at compensation packages north of $250,000. Right now, the sheer speed of AI development is basically limited by how fast crews can dig trenches and pull high-tension cables.
Now, transitioning from the physical dirt to the virtual world brings us to our second huge career shift: digital twin construction engineers.
Jensen made a pretty brutal but accurate observation recently. Construction is the world's largest industry, but it's arguably the least digitized. So to fix that, they're leaning heavily into the Omniverse digital twin. Instead of unrolling 2D blueprints, engineers are using NVIDIA's Omniverse platform to build a living, breathing, physics-accurate digital replica of the whole site, way before a single shovel even hits the dirt. They can simulate supply chain logistics, optimize exactly where a crane needs to go, and spot major safety hazards in real time, all inside this fully functional virtual sandbox.
And because of this, the financial reality of this role is just exploding. Industry giants like Jacobs and Turner Construction are literally mandating that every single new mega project uses an AI-driven digital twin. So think about it. If you're a construction manager who knows how to strap on an AR headset, walk out onto an empty concrete slab, and perfectly overlay a digital plumbing grid to see exactly where a pipe needs to drop before you cut, you just saved them from flooding $1 billion server room. You are going to be in incredibly high demand. We're looking at a severe 3-year specialist shortage here, which means these digital twin architects are effortlessly commanding salaries between $120 and $200 a year.
All right, let's pivot to the third massive shift we're seeing on the ground: robotics fleet managers.
We are officially entering the era of physical AI. NVIDIA laid the groundwork for this back in July 2026 when they partnered up with heavy equipment titans like Caterpillar and Komatsu. And if you break down the features of the job, it really directly addresses that whole fear of automation taking everyone's jobs. It's actually an evolution. You go from being a heavy equipment operator sitting in a dusty, vibrating cab pulling manual levers for one single machine to a robotics fleet manager. Now you're sitting in a remote, climate-controlled trailer. You're tele-operating a whole swarm of 10 or more autonomous machines at the exact same time. Your core skill completely shifts from manual dexterity to troubleshooting AI telemetry, specifically on platforms like NVIDIA Jetson Thor. You're analyzing data on the fly, ensuring the physical safety of your robotic crew. So you aren't being replaced, you're just being upgraded to a highly valued, highly skilled supervisor.
But obviously, that begs the question. Where exactly do all these highly skilled workers actually come from? Well, that brings us to a massive training shift where Silicon Valley is finally meeting the union hall. Jensen Huang has actually gone on record declaring that a lack of skilled tradespeople is the Achilles heel of the entire AI revolution. And because of that, Silicon Valley money is quietly but very aggressively being pumped straight into state-level trade schools and union apprentice programs. If you're entering the trades right now, these 3 specific disciplines are your golden roadmap. I mean, the construction site of 2028 is going to look like a literal sci-fi movie set. Plumbing apprentices aren't just learning standard pipe fitting anymore. They're getting deep into highly complex refrigeration and liquid immersion cooling systems. Electrical apprentices are studying DC power distribution and microgrids. Hell, even general foremen are learning Python basics so they can interact with site management AIs and handle modular logistics, using AI to stack prefab pods with absolute millimeter precision.
But of course, there is a catch, and it is a big one. Let's talk about the ultimate infrastructure bottleneck.
If you dig into Jensen's Q2 2026 financial reports, there is a very stark warning hiding in plain sight. Time is the ultimate enemy here. Just consider the ridiculous disparity in lead times right now. NVIDIA can design, fabricate, and ship a radically faster next-generation AI chip every 2 years. But actually building the physical AI substation required to power those new chips, that takes 4.5 to 5 years. The physical world simply cannot keep up with digital innovation. In fact, this bottleneck is so severe right now that tech giants are desperately scrambling to buy up and retrofit abandoned steel mills and old aluminum smelters, literally, just because those sites already have massive, gigawatt power hookups physically connected to the grid.
So, the big, crucial takeaway from all of this. The race to artificial general intelligence, AGI, well, it's no longer just a race of software algorithms happening in some sterile lab. It is a grueling, boots-on-the-ground physical race of local permit approvals, concrete curing times, and somehow navigating the global supply chain just to get your hands on a substation transformer. This lag has created an ultra-urgent demand for brilliant project managers who can actually navigate these insane permitting mazes and utility bureaucracies, because proving you can build the future means you absolutely have to figure out how to build it faster, smarter, and way more efficiently in the physical, blue-collar world.
The cloud is no longer just code floating in the ether. The cloud is made of concrete, copper wire, and miles of cooling pipes. So as we wrap up this explainer, I want to leave you with one final thought. When this digital revolution finally hits the physical dirt, do you have the blue-collar, high-tech skills to build the future? The construction industry isn't just about brute force anymore. It's about high-tech horsepower. So take a look at where you might fit into this trillion-dollar puzzle. Thanks for hanging out, and I'll catch you in the next explainer.